What is the theory of relativity and how does it work? The theory of relativity was developed by Albert Einstein in 1905. The theory of relativity is a physical theory that explains how measurements of space and time are related. It has been tested and confirmed many times during the 20th century. It is based on two postulates. 1. The laws of physics are the same for all observers, regardless of their state or motion. 2. The speed of light in a vacuum is constant for all observers, regardless of their state or motion. Einstein thought that these two postulates would lead to an inevitable contradiction, but he found a solution to this contradiction by introducing his famous equation E equals mc2. The first postulate that the laws of physics are the same for all observers is true in special relativity because it applies to different frames of reference. The equations of special relativity are linear and therefore remain identical for any observer who moves at constant velocity with respect to a given inertial frame of reference. The second postulate that the speed of light in a vacuum is the same for all observers, or is true in special relativity because all observers share a single frame of reference. In special relativity, the postulate that speed of light is always measured in a vacuum assumes a drastic change in perspective. In Newtonian physics, the speed of light is always measured relative to an observer who has an absolute reference frame as their fixed frame. The light has an absolute velocity of 60 miles per hour. In special relativity, the measurement of the speed of light is always measured relative to an observer who has no such frame. If you travel at 60 miles per hour on a straight highway with headlights on, then your relative velocity will be different than if you are riding a bike on the same straight highway. If we had no special theory of relativity, then the speed of light would be constant for all observers. This is not the case in general relativity or special relativity, but only in special relativity does this result from Einstein's theory. Since the speed of light is a constant, it means that no change in the speed of light will cause any change in length. This is not true for all speeds, but only for very fast speeds. For example, if you were to move your foot an inch forward while measuring a meter with a ruler, then you would measure 0.2 meters. Instead of 1 meter because your foot is traveling at a far faster speed than light. The special theory of relativity was developed to determine the effects of motion on the properties of length and time. The concept that it is impossible for two objects to have simultaneous different speeds in inertial frames is called the principle of relativity. It is possible for two things to be in different states of motion, but the principle of relativity requires that there is no difference in the way each state appears to observers moving with respect to one another. For example, if you are moving toward a stationary observer, then your state of motion will appear slower than the stationary observers. What is special relativity, and how did Albert Einstein create it? Einstein's theory of special relativity is a theory that deals with the relationship between time and space. It was developed by Albert Einstein in 1905. Einstein began to think about the issue of time and space when he was working on his dissertation. He thought about how light moves at different speeds depending on whether it is moving towards or away from an observer. Einstein's theory of special relativity states that all physical laws are invariant with respect to any frame of reference, including the principle of relativity. This means that they are the same for all observers, regardless of their state or motion relative to each other, so long as they are moving at a constant velocity relative to one another. The theory also postulates that there is no absolute frame of reference from which all observers can agree. Einstein's theory of general relativity is an extension of his 1905 special relativity theory. It comprises a geometric structure with two parts. The first part of the theory describes how matter and geometry are interwoven to create a universe in which time is the fourth dimension. The second part is a dynamical system which describes how matter curves and warps the 3D geometry, creating gravitational fields and accelerating clock-measured time. The Big Bang theory is a theory about the origin and evolution of the universe, which states that it began with the explosion known as the Big Bang around 13.8 billion years ago, expanding rapidly from an extremely hot, dense state. The Big Bang theory is as follows. 1. At one point in time that has not been specified, spacetime did not exist and energy was the only thing that existed. 2. As the universe continued to expand, spacetime began to form and collect energy into particles. 3. When it became dense enough, it created the first quark that glowed and caused an explosion at a temperature of 10 to the power of 9 Kelvin, 10 to the power of 14 Celsius. 4. As spacetime slipped, quarks clumped together, forming atoms. 5. When the temperature of an atom reached 1012 Kelvin, 1015 Celsius, it created electrons and neutrons that formed hydrogen and helium in the early universe. 6. The electrons gave off photons and protons with energy that caused quarks to stick together, creating neutrons, protons, and electrons. 7. As thermonuclear reactions took place, these particles clumped together to form hydrogen and helium. 8. By this point, the temperature was 1015 Kelvin, 1018 Celsius. 9. The first heavy element was created as nuclei of hydrogen and helium combined and became unstable. 10. This element would have had a half-life of 30 minutes at this point due to the instability of its nuclei. 11. As time progressed, these heavy elements would have decayed into lighter elements. 12. More stable nuclei would have been created as they broke down into neutrons, protons, and electrons. 13. The early universe was mostly hydrogen and helium, with traces of deuterium and lithium. How can you use Einstein's theory of relativity to improve your life? Einstein's theory of relativity is a theory that is widely accepted by scientists and scholars. It is one of the most important theories ever created. Einstein's theory of relativity explains how time and space are related to each other. It also provides an explanation about the relationship between mass, energy, and acceleration. Many people have found ways to apply Einstein's theory of relativity to their life in order to improve it. Einstein's theory of relativity, TR, is one of the most important discoveries in modern science. It has allowed scientists to understand a wide range of phenomena such as light bending around a massive body, non-uniform motion, and gravity. TR made numerous predictions that have led to our current understanding of today's world. However, there are some things still unknown, such as the structure of spacetime. It is a candidate for a more complete theory than GR, but its claims are not experimentally verified and it is not considered generally accepted as a description of reality. The theory of general relativity was created by Albert Einstein after his experience with non-Euclidean geometry in 1907. In the years following, he developed a cosmology that is based on Newtonian and Euclidean physics. This theory applied these concepts to the universe as a whole, while replacing all mention of gravity with curvature of space and time. The theory of general relativity is a much more complete theory than GR, but its claims are not experimentally verified. And it is not considered generally accepted as a description of reality. E equals mc2 is not just an equation, but one that describes the fundamental laws governing matter and energy. This equation states that mass can be converted into energy and that energy can be converted into mass. This is because the concepts of time and space are relative to the observer who makes the observation. Einstein received his doctorate from the University of Zurich, Ph.D., in 1905, with a dissertation on Brownian motion. On the influence of gravitation on the movements of particles suspended in a stationary liquid, 1905. Einstein's first paper introduced his theory of gravity as a distortion in the fabric of spacetime caused by mass. In this paper, Einstein also introduced his light postulate, which said that the speed of light in a vacuum was constant. In 1907, Einstein contributed to the foundation of quantum mechanics by publishing 6 groundbreaking papers on special relativity in less than 1 year. His most important paper of that year was Does the Inertia of a Body Depend Upon Its Energy Content?, in which he introduced his famous E equals mc theory. Stay tuned for part 2 of the secrets of Albert Einstein's formulation of special relativity, and don't to subscribe to my channel please, thank you.